Welcome back, Algebra 2. We're in lesson 67, and I just wanted to point out, before you hear it and wonder what's going on, this is New Year's Eve, December 31st, and there are people doing fireworks in my neighborhood, so you might hear them in the background. And you might also, Roscoe is asleep at my feet. If he hears them and gets scared, you might hear him as well. So I'm just going to give you a heads up that might be something you encounter in this lesson, and I'm gonna try to keep him calm in the process. All right, so we're talking about radical denominators in this lesson. Remember when we had some radical denominators? Let's say we had 3 over the square root of 2, and we don't like that. We don't like to have a radical in the denominator. It's irrational. We can't do anything with it. And in algebra, we want to get rid of that radical as much as possible. So what we would do is we would multiply the numerator and the denominator by the radical that was in the denominator. And we would end up with 3 times the square root of 2 over 2, right? Because a radical times itself becomes the number underneath the radical sign. Okay? So, what about, we're going to move into some more complicated equations. Whenever we have more complex radical expressions in the denominator, we have got to get rid of them. So, for instance, we have 1 over negative 4 plus the square root of 3. That's hard to get rid of. What we have to do in algebra, and this is 67.1 by the way, what we have to do in algebra is we have to multiply this by what's called the conjugate. Now the conjugate is easy to determine. We just change the sign between these two. The conjugate of negative 4 plus the square root of 3 is negative 4 minus the square root of 3. And we have found, people smarter than I have figured out that when we multiply this times this, or the conjugates against each other, that we can solve it into a perfect square. So that's what we want to do. We want to use the conjugate and multiply the top and the bottom by the conjugate to get rid of the radical sign. So that's what we're going to do here. We're going to just say multiply by negative 4 minus the square root of 3 over negative 4 minus the square root of 3. And then this, of course, 1 times that is going to be this. But now we have to do some math to figure this out. So what we do is we do what's called a stacking method. Now you can do the distribution method. That works just fine. But there's also another method that goes along with stacking, and that is where you layer and you do your square roots. We layer these numbers on top of each other, and we multiply just like we would multiply regular numbers. We draw a line, and we say the negative square root of 3 times the positive square root of 3 would give us negative 3, because a negative times a positive is a negative, right? This times this gave us that. Now we say negative square root of 3 times negative 4. Negative times negative gives us 4 times the square root of 3. Right? Do we see that? Okay. So now we do negative 4. So negative 4 times the positive square root of 3, that's going to be a negative. This is a positive. Negative times positive is negative, so negative 4 times the square root of 3, that gives us that. Now we say negative 4 times negative 4, we get a positive 16. So if you look, this has created a perfect square, just like we said up here, and it eliminates this square root, because a negative 4 times the square root of 3 and a positive 4 times the square root of 3 cancel each other out. So then we're just left with the whole numbers. 16 minus 3 is equal to 13. And that's what we would put here. All right, do we see how that works? Now, again, I said you could use the distribution method. This is the distribution method. It's just used in a full stacking format. The other distribution method is where we labeled each line. So let me review that to you as well. We would say -4 plus the square root of 3. All right, that's our first term, times -4 minus the square root of 3, which was our second term, right? And if this is how you have to do it, if this is what is easier for your brain to see, then do what your brain needs. So we would take -4 first. And we'd say -4 times -4 is a positive 16. -4 times a negative square root of 3 gives us a positive 4 times the square root of 3, because a negative and a negative are positive. Okay, then we would move on to the square root of 3. Positive square root of 3 times a -4 is -4 times the square root of 3. Positive square root of 3 times negative square root of 3 is -3. -3, these cancel. 16 minus 3 is still 13. So you can do it like this and stack, or you can do a full stack and lay these on top of each other and take this one times this one, this one times this one, this one times this one, this one times this one. Okay? If this is too complicated or confusing, do it this way. You're going to get the same answer. It doesn't matter. All right, so let's try another one. Let's do 67.2 and practice some more. Let's clear the page. 67.2. This one is 2. No, it's not 2. Sorry, wrong number. This is a 3 all over 2 times the square root of 3 plus the square root of 2. So the conjugate to this is going to be 2 times the square root of 3 minus the square root of 2, because it's the opposite sign, and we just repeat that. Okay, so we know what this becomes. This distributes, right? And it becomes 3 times 2 is 6 times the square root of 3 minus 3 times the square root of 2. Right? Because 3 times 2 and 3 times -1, right? This invisible one right here. We've talked about that before. So don't forget it. There's always an invisible one whenever you have a minus sign. Okay? All right, so now let's do this one, and we're going to do the stacking. So we're going to do 2 times the square root of 3 plus the square root of 2. 2 times the square root of 3 minus the square root of 2. Draw our line. -2 times +2, both square root, gives us a -2. Negative square root of -2, or the negative square root of 2, times 2 times the square root of 3. So this is a -1 right there. So -1 times 2 is a -2. And square root of 2 times square root of 3 is the square root of 6. Negative square root of 6, right? So now do the same thing. 2, there's an invisible 1 here. 2 times 1, that's +2. Square root of 3, square root of 2 is the square root of 6, right? Okay, now 2 times 2 is 4. Square root of 3 times square root of 3 is 3. So that's 4 times 3. That becomes 12. So we add everything together. -2. These cancel. We bring the 12 down. 12 minus 2 is 10. So 10 would be our answer. All right. These are easy. They're not so hard. All right, so let's do one more. I'm going to clear the page. And let me see if I can find one for you. Okay, here we go. This is one I'm pulling from the lesson practice because we're not going to be doing it in class. This is 2 all over -4 plus the square root of 5. All right, so the conjugate for this is -4 minus the square root of 5. We're going to multiply both the top and the bottom by that. Okay. 2 times a negative 4 is a negative 8. And 2 times negative 1 is going to be a negative 2 times the square root of 5. All right. So now we do our stacking. We say negative 4 plus square root of 5, negative 4 minus square root of 5. Draw our line. Negative 5 times positive square root of 5. If you have negative and positive, this is always just going to be the negative whatever number this is. So we just write negative 5 down here. Now this is going to be negative and negative. This is going to be positive 4 times the square root of 5. Negative positive is going to be negative 4 times the square root of 5. Okay? Negative times negative is positive. That's going to be 16. These cancel. 16 minus 5 is equal to 11. 11 goes here. All right, not super difficult. Once you figure out the organization of how the stacking works, it's pretty straightforward, and then that is how you can get a whole number on the bottom. All right. Okay, so that's all we have for lesson 67. I will see you guys in lesson 68.